Hello everybody. So today we are going to be going over factorization. Now we are just going to be revising over some grade 10 factorization so that we are able to kickstart our grade 11 here. So let's get straight into it. So first things first, what if I were to give you a question such as x squared minus 2x? Okay, now when we come to highest common factor, and I apologize for not pointing it out first, highest common factor is essentially when we see one thing that repeats itself in every single term. So take note that each and every single expression is going to be a term divided by either a addition sign or a subtraction sign. So this is just going to be the first term, right? And this is just going to be the second term. And then if we were to add another one, such as let's say ax plus b, y, or whatever, this will be the third term, and this will be the fourth term, and so on and so forth. Hopefully that makes some sense. But anyway, now that we got that out of the way, we can now understand what is it that we are actually going to do. We are going to take the highest common factor from these two terms. And what do we notice? We can break the x squared into x multiplied by x, right? Minusing it by 2 multiplied by x. What is the common factor between these terms? Well, clearly x is repeating itself in both terms. So this is a method which we call highest common factor, and we will take out this factor such that what we're going to have is x multiplying into, we take the x out from here and also out straight to the front from the other term. And then what are we left with? The remainder, which is going to be x minusing by 2. Just the remaining stuff that we are going to take inside of the bracket. So what are we left with the first term? We're left with x. And if we minus it, we're going to minus it with 2. And that is going to be our answer for the first one. Now let me give you another one, okay? So what if I were to give you the following? If I were to give you x to the power of 3 plus, let's say maybe 4x to the power of 2. Well, let's break this up because now we have two terms. Or why not give you another term? Because why not? Plus, or let's give you minus x. Now let's break this up for each one of them. X to the power of 3 is written as x multiplied by x multiplied by x. Plus 4x to the power of 2, which can be written as 4 times x multiplied by x minus x. What are the common factors? Well, if we look at each term, we notice that x is here, and in the second term, we can see there's also an x, and then in the third term, we notice there's also an x over here. But in the third term, there's only one x. Whereas in the first two terms, we do have two x's, obviously. But because the last term only has one x, then clearly we can't take out two x's from each of them. We have to take out the highest common factor. And notice that everything is in common when we take out x. Everything has x and x alone. So therefore, we're going to say that this is equal to, we're going to take out all the x's from each one, and therefore it's going to be x into, some teachers use you call it a square bracket. But some of us use parentheses, which are open brackets described. So we take out x, and now what are we left with? X times x, 4 times x, and notice that 1 is just being multiplied by x by default. So therefore, it will be x multiplied by x plus 4 multiplied by x minus 1. And notice if we were to simplify this, therefore it will be x goes into x times x, which is x squared, plus 4x minus 1. And obviously for this one, we can't factorize it normally, but we can use a quadratic formula, which I'm not going to go into yet. Okay, so that would be highest common factors. Let's get straight into the next one. So for this one, it's almost a different situation. So we are going to recognize a rule now, a property that we need to remember. So in the last one, when we took out highest common factors, we clearly saw that there were repetitions. But in a case where we have two terms only, there's a subtraction sign that is between the two terms. We call it a difference of two squares, where the difference is just denoted by the negative sign and two squares is denoted by both the terms being perfect squares. So take this for example. If we have x squared minus 4, very basic example, do you notice that these are actually two perfect squares? Why? Because we can see that x squared is written as x multiplied by x, and we subtract it by 4, which can be written as 2 multiplied by 2. Right? And clearly we talk about perfect square because 4 can be written as a number multiplied by itself, such as 2. Obviously we don't have common factors, but what we can take out is a rule. And a rule says that if we have x squared minus a squared, where x is the variable and a is the constant, then therefore we can say x is subtracted by a, multiplied by x, adding by a. And this is something, if you remember and you see the patterns over and over, you'll be able to apply them. So let me actually just take this and I'll put it just above over here. Okay. So let's now actually answer this question, right? So here, what do you notice? We have x squared minus a squared, where clearly x is represented by x and a is represented by the square root of 4, which is going to be 2. Because remember, it's a squared. What multiplies itself twice? It is 2. So a squared will actually be 4. And if you want to solve for a, you can always say a squared is equal to 4. And then you take the square root on both sides. And then we'll have the square root of a squared is equal to the square root of 4. And because we don't work with absolute values in high school, we can just say they cancel out. And we'll be left with a is equal to plus minus 2. And in this case, we are just going to choose the positive for this one. So let us take into consideration that we have x squared minus 4. In this case, x squared minus 4, she's hectic, I'm turning into Mickey Mouse here, is equal to x, notice that it's just one of the x's, minus a, which is going to be what? The square root of 4 is going to be 2. So it's going to be minus 2 multiplied by x plus 2. So notice our a value is just going to be 2. Because this is also just 2 squared over here. Okay, I hope that makes sense. Let's do another example here. So if I were to give you an example, right, such as, let's say, 27x to the power of 2 minus 12. Now you're probably going to be questioning, why on earth do we have 27 and why do I have 12? These are not two perfect squares, but we notice that x squared is a perfect square. Now this is where we're going to go back to our previous step, which was highest common factor. So what is the highest common factor in this case over here? What goes into 27 and 12 at the same time, which is the highest? If you said 3, then that is 100% correct. So we can take 3 out as a common factor. You can actually just break it up, such as 3 multiplied by 9, okay, for the 27, and for the 12, you can write it as 3 times 4, meaning you can take out 3 as a common factor, and then you'll just be remaining with the 9 and the 4 in the bracket. So it'll be 9x squared minus 4. Alright. Now what do you notice from this? 9 is a perfect square, which is 3 squared. X squared is also a perfect square. And 4 is also a perfect square, such as 2 squared. So therefore, what do we notice? We're going to use this rule, x squared minus a squared, where x squared can actually be represented by the following, right? So look here. Notice that we can write it as 3 multiplied by 3 squared x squared minus 2 squared. And I hope this would be easier to see. Now, if you remember from exponent laws, do you notice that the 2 is repeated in the exponents? So we can use exponent laws to say that we will take out the square, such as we're going to have 3 times x to the power of 2. Because remember, then if you want to take it back in, you're going to take it to each of the 3 and the x. So it'll be 3x to the power of 2 minus 2 squared. And therefore, this is just represented by your x, the 3x, and this is represented by your a, the 2. Okay. So there's some analysis there, and therefore we're going to have 3 multiplied by difference of 2 squares. It's going to be 3x minus a, which is going to be 2, and then it's going to be x, which is just 3x again, plus 2, using this rule over here, if that makes some sense. Okay, so you'll get those tricky questions, and I would recommend trying to do more of those questions to get used to it. So let's get to the next part. Alrighty, so now we got to one of the trickier ones out of the 3 that we are doing so far. So if I were to talk about trinomials coming from the tri means 3, right? So meaning we have 3 terms. That is what trinomial means within an expression. So what if I were to give you the following? If I were to say x squared plus 8x plus 15, right? What I want you to do is the following. I always want you to look at the first term and the third term. And this is where you do the breaking up. And then when you break them up, I want you to take consideration of the middle one, but we'll get to that one. Okay, so first things first, on the left hand side, we note that x squared can be broken up into factors of x multiplied by x. That's what gives us x squared, right? But 15 can be broken up into many things, such as 3 multiplied by 5, and 3 multiplied by 5. And in order to understand how to use these factors, and we can just take this as is, but how do we know this is true? Well, usually if I say that the sum or the difference of the factors that we break up gives us the value in the middle, then therefore that is what we are going to take. So do you notice, do these factors add or subtract to give you 8? Well, clearly they add each other to give you 8, because notice that is just going to give you 8, 3 plus 5. So we are going to do it as follows. We're going to write these 2 brackets like so, and then we are going to do the following. We have x multiplied by x. We write down the left side. We keep the left side on the left side essentially. So if we say x, we keep it on the left, and then we'll focus on the signs now. But the other values, such as 3 and 5, it really doesn't matter where you put these, but the only things that matter are the signs. Now, what do we do with the signs? Notice that we have 2 positives. This positive, the first sign that we have over here, goes to the one with the highest value. What is the highest value out of these 2? Clearly, it's going to be 5. So the positive goes there. And then the second one, let me just do it in a different color. The second sign is also a positive. We'll go into another example, you'll see. This goes to the remaining. Okay, but the thing is, you are not going to immediately take it as positive immediately. You are going to take this sign and you're going to multiply it by that sign in order to get your final sign. Meaning a positive, and a positive in this case gives us a positive. If it was a case of a positive and a negative being here, then clearly it's going to give you a negative over here as an output. But let's use that in the next example so we don't get so confused. So what if I were to actually keep it as is, or kind of? So we have x squared but plus 2x. But now we are going to subtract it by 15. So notice we're going to do the exact same thing again. The x squared, we multiply x by x to get x squared. The 15, we multiply 3 by 5, and that is what we can really do at the moment. And we can also do 1 and 15, by the way. That's also possible. But like I said, in the previous one, we need to take one of these factors, either add them or subtract them to get the middle value over here. And if that one works, we use that group of values. So which one out of the 2 gives us 2 if we either add or subtract? Well, notice if we take 1 and 15, we can't get 2 out of 1 and 15 if we add them or subtract them together. But for 3 and 5, clearly if we say 5 minus 3, that does give us 2. So it's a little bit of like a maneuvering type of method. So notice that we have 2 here from 3 and 5. So therefore we have to use 3 and 5, if that makes sense. Okay, so I'm going to actually keep that there. And now we're going to go to our brackets, okay? So our brackets goes as follows. Notice the x and the x are both on the left-hand side over here. And on the right-hand side, we have the constant value, which is going to be 3 and 5. Like I said, the value order doesn't matter. You can put a 5 here as well if you want to, but the sign matters. What did we say about the sign for this one over here? Notice that the highest value is always going to be affiliated with the first sign from the trinomial. So 5 is clearly going to get the positive. But now here for the second value we have a negative. And the negative, remember when I said the remaining one is going to multiply by the first sign and then we're going to output it in the actual answer. So a negative, we are going to take that and we are going to multiply it by the positive. And a negative and a positive gives us a negative. So that is what we are outputting, if that makes sense. I would recommend using the same method and trying it out for the rest of the questions. Let's move on to the next method. Okay, so this one is a bit of an interesting one. So if we have a case where we have a difference, or I guess an addition or a difference of 2 cubes. I know for the other one we had a difference of 2 squares only. It doesn't usually work for an addition of 2 squares. But this case, it works for both addition and subtraction. So in this case, when we work with a cubed plus or minus b cubed, what that is saying is we can choose between the positive and negative and we'll get the following. So let's say a case where we choose the positive, right? We'll get a and it is going to be positive b. So a plus b multiplied by, and then we're going to have a square plus, or I guess, sorry, minus, it should be ab plus b. Okay, so when it's a case where it's addition, okay, then clearly we are going to choose the positive and the negative and then the positive, okay, in this order. But when it comes to a case where it's negative, then in the first bracket it's going to be negative that we are choosing, okay, and then in the second bracket this will be a positive that we are choosing. Okay, so I'm going to break it down into the 2 steps now. Okay, so if it was the case where it was a cubed plus b cubed, then therefore that would be a plus b multiplied by a square minus ab plus b. You can even try and multiply them in together and then you should get something like this. But in the case where it is going to be a cubed minus b cubed, so a difference of 2 cubes, it will be a minus b multiplied by a square plus ab plus b. I just thought I'd put this one in because obviously then you can just choose between the signs. So if I choose the positive, notice it's going to be positive, negative, positive. If I choose the negative, it'll be negative, positive, positive. Okay, so just remember those ones. This is how it's broken up. Now let's do some examples, right? So what happens if I give you the following question? So let's say I say we have, let's do 27x to the power of 3 plus y cubed. Now I know this is a little bit of a funny one. I'm actually going to rather do 8. Now what do you notice? Do you notice that 27 is a perfect cube? It is just 3 cubed. X cubed is also a perfect cube, and 8 is also a perfect cube, which is 2 cubed. So do you notice that clearly in the case where we have to factorize and whatnot, since 27 is also a perfect cube, we can say 3 cubed x to the power of 3 plus 2 to the power of 3. And what do you notice? Exponent laws again. So we are going to take this out and say 3x to the power of 3 as the exponent laws of multiplication state, multiplication of bases, sorry. plus 2 to the power of 3. And do you notice that we have it in the form of a cubed plus b cubed. So therefore we just plug that in, right, to what we have. So it's a cubed plus b cubed. So we're going to be using this one over here. So a cubed plus b cubed is just equal to a plus b, which is just 3x plus 2, right? Notice that I circled them and just indicated them, okay? Multiplied by a square. What is a square? It's just going to be 3x to the power of 2, and it is going to be minus. Notice the minus comes first, and it's a times b, which is what? 3x multiplied by b, which is 2. And then we say plus b, and sorry, by the way, it's b squared. I completely forgot to put that in, so I do apologize about that. It's all b squared. I'm supposed to close this bracket. Okay, so I hope I know some of you are probably screaming at that screen. It's like, I know what is going on here. I know everything. But at the same time, we're human. But at the same time, I shouldn't be making these mistakes. But anyway, notice that the b squared is supposed to be there. Okay, so now we are going to have b squared, which is just what? 2 squared. Okay, hope that makes sense. And then obviously you would just simplify it because that's your job to do. 3x plus 2 multiplied by 3x squared, which is just 9x squared. If you just take the exponent in using exponent laws, okay, minus 3x times 2. What is 2 multiplied by 3x? It's just going to be 6x plus 2 squared, which is 4. There we go. There, we just factorized it now, right? And then obviously for this one, I don't think you can factorize this one simply. So therefore we'll just leave it as it is. But this is the idea that we are getting from perfect cubes. And I want you to try an example when we have a cubed minus b cubed. Let's get to the final part of this revision. Okay, but before we do, let me just give you an example question. So example 1 question. If I give you x minus y to the power of 3, and I say minus 64x to the power of 3, what is the answer going to be? How are you going to factorize it? So I want you to try that on your own. Okay, now let's actually get to the final part. Righty-dighty. So if we have the following, this is rules of fractions, okay? So we're going to do the rules of fractions quickly, then we're going to do one question, and then we'll call it a day for this lesson, okay? So if we have a case where it's a divided by b, okay, and we multiply it by, let's say, c over d, okay? So in this case over here, we have a over b times c over d, and if we multiply two fractions, the numerator will multiply by the numerator, and the denominator will multiply by the denominator, such that we are going to have a, and then we're going to put it into one fraction, such that we have a times c divided by b multiplied by d. And therefore, we can actually write it as AC over BD. So that's our first rule when it comes to fractions, okay? Now, what if the case is when we have A over B divided by C over D? Then what are we going to do? Okay, in this case over here, this is what we call tip and times. We don't like division. So therefore, we are going to rewrite it as a multiplication because we want to go back to rule 1. We love rule 1 because it's so straightforward. Numerator goes to numerator, denominator goes to denominator. So what are we going to do? We are going to tip in times. We're going to look at this. We're going to say, no, I want a multiplication. So what I'm going to do, I'm going to use the rules of math, and I'm going to say this division turns into a multiplication, but in order for it to be valid, we are just going to do the following. We are going to swap these two. We're going to swap the numerator and the denominator such that we get d over c. Okay. And therefore, we just can have a different answer where we have a times d. Right? Okay, we're going to use our rules of fractions when it comes to multiplication. Numerator times the numerator, denominator times the denominator. Therefore, we have AD. A multiplied by d divided by b multiplied by c, and that is AD over BC. Can you see the difference here? Last one we had just multiplication, but this one we had division. So we forced our way to use the first rule because we love the first rule. Therefore, notice that we have the multiplication, but in order for the multiplication to be valid, we need to swap this fraction. Now we're going to get from C over D to D over C. And then we use our rules of multiplication, which is from the first rule. Okay. And now we are going to get to the final rule. So let's say that we have A divided by B plus or minus. So it can either work with addition or subtraction. Let's say B, or let's say C over B, sorry. And what do we notice? First things first, do you remember common denominators? If we have common denominators under the rule of addition or subtraction, therefore we can put it into an entire fraction on itself, where the denominator stays the same. But now what you notice is that the numerators will add with each other. A plus minus C divided by B. The denominator will share with these two terms. And obviously, in the case where we want to do it the other way around, this is true if and only if. Don't worry about the symbol. I'm just saying it can be done both ways. We can say A plus minus C divided by B is just going to be equal to the fact that we can literally do what we did here, right? We took the AB and we added or subtracted with C over B, and we got this as an answer. So that is what we are going to do. Let me actually keep that over here. Therefore, we are going to do the exact same thing. We're going to say A over B plus minus C over B. Okay. And therefore, that is what we are going to actually have, plus minus C over B. We can break it up that way as well. So let's do an example. I don't know if we're able to use all the rules for this one, but let's just try it and see what happens. Okay. Right, hey. So we are going to do this. Here's our question. It is all of that, and I'm not going to read all of that, okay? So the first thing that we need to do is just look at every single trinomial that we have. We have so many trinomials, and it's ridiculous how many we have. So first things first, let's look at the first one, the one on the top left. We have x squared plus 5x minus 6. So what do we remember? X multiplied by x, and then we have, what gives us 6? It will be 3 times 2, or 1 times 6. So which one is going to give us 5? In this case over here. Okay. But here we lie with a little bit of a problem. 1 and 6 can give us 5 if we say 6 minus 1. And 3 and 2 can also give us 5 if we say 3 plus 2. So how do we actually check? So let's actually do a test to see which one actually gives us this whole trinomial as an answer. So we are going to try 1 and 6. Okay, so x, remember our brackets here, okay? So it's going to be x and x on the left hand side from here, and then let's use 1 and 6. So we say 1 and we use 6, and then over here for the first sign, notice that it's a positive, the first sign, so the positive goes to the biggest one, the highest value. And then because it's a negative, we're going to multiply the negative with the positive, and the answer that we get for the remaining bracket is going to be negative and a positive. That gives us a negative. And then from there, what we notice is that if we use FOIL method, which is x times x, which is x squared, and then it's going to be the first in the outer, which is x times 6, which is going to be plus 6x, and then it's going to be the inner, which is negative 1 times x, which is minus x, and then negative 1 times 6, which is minus 6. If we simplify that, that's going to be x squared plus 5x minus 1. So this one seems to be working with us right now, okay? But let's try the other one. So let's do the brackets here. And by the way, this is in the case where we have to choose. We need to verify. Okay. So now, from this one over here, I'm just going to get rid of this. Let's choose 3 and 2, okay? So let's say x on the left-hand side, then we have 3, and then we have 2. Now for the signs, biggest one is a positive. And then the second sign over here is clearly going to be where we take the negative, the second sign, and multiply it with the positive, and then we get the remaining sign, which is negative. And this is equal to, after we use FOIL method, which is first, which is going to be x times x, which is x squared, the outer, which is x times negative 2, which is minus 2x, inner, which is 3 times x, which is positive 3x, and then 3 times negative 2, which is negative 6, and x squared minus 2x plus 3x, which is just equal to positive x minus 6. Now my question, is this the same as this? No, it's not. So therefore we can say that this is not the method to go. We cannot use 3 and 2. Let me say that in a different color here. We cannot use 3 and 2. Therefore we have to use 1 and 6 as this one. So therefore we can write down here x minus 1 and then x plus 6, and then we can do our division sign. Okay, I apologize about that. So we have that. Now we're going to work with the denominator. Okay, so we have x squared plus 2x minus 15. Now clearly 15 can be written as 1 times 5, and it can also be written as 3 times 5. Did I say 1 times 5? I mean 1 times 15. I'm so sorry. But notice that 1 and 5 can't give us 2, clearly. But 3 and 5 can give us 2 when we say 5 minus 3. That's the only combination that can give us 2. So therefore we can just say over here, x for our first bracket and then x for our second bracket. And we say 3 and 5 or 5 and 3, whatever. And then our biggest sign, which is positive, goes to the biggest value. Sorry, our first sign goes to the biggest value. And then the second sign is negative, so negative times positive gives us a negative for the remaining. There we go. And then we have divided by, and now we're going to move on to the next one, which is x squared plus 8x plus 12. Can you see how there's a rhythm to all of this now? So now what are the factors? Clearly we have x times x and we have 12. And 12 can be broken up into 3 and 4. It can also be broken up into 2 and 6. And then also 12 and 1. But what gives us 8? 3 and 4 does not give us 8, clearly, it never does. 2 and 6 can give us 8 when we say 2 plus 6, and 12 and 1 can't give us 8. So therefore we will use 2 and 6. So therefore it will be x over here for our brackets, x, and then we have 2 and 6. And then from here, what do we do? Okay. Our biggest sign, or our first sign, is going to be positive, so it goes to the biggest value. Our second sign is positive. Positive and a positive gives us a positive as a remainder. Okay, hope everyone is fine with that one. And now we go to our last one, our final one, which is x squared plus 7x plus 10. Here we do our brackets again. Let me just do that first, I suppose. And then from here, notice we have x squared, so therefore it'll be x both on the left hand side because it's x times x, and then 10 is broken down. I'm going to do it in a different color. 10 is broken down into 2 and 5. It's also broken down into 1 and 10. Okay, and clearly we need to get 7, and we can see that 1 and 10 clearly doesn't give us 7, so we can't use that. So therefore we'll use 2 and 5 because 2 and 5 can give us 7 when we add them. So 2 and 5. And the first operation, which is the addition, goes to the highest value. Second operation multiplies by the first operation to give us the remaining sign. Positive and a positive gives us a positive. Okay. Now I know that you guys are definitely confused in the beginning, but the more you see this in action, the more you do it, the more it makes sense, and the more you're able to recall it. It becomes second nature. Practice makes perfect. You'll never get everything on the first try. That is my advice to you. So just keep doing it. Just keep doing it, man. Just keep swimming. Okay, this is getting ridiculous. Anyway, so we have a division sign, right? What do we remember from rule 2? Rule 2 is when we tip in times. We don't like division. We like multiplication. So remember the rule said that we can swap this to a multiplication, but clearly we have to flip these two to get around the numerator and the denominator. Then we can change it to a multiplication sign, and therefore we'll have the following: x minus 1 into x plus 6. I know I'm writing very small, divided by x minus 3 multiplied by x plus 5 multiplied by, and then we are going to have swap them around. Now we're going to swap the numerator and the denominator, so now we're going to have this on the top, x plus 2 multiplied by x plus 5 divided by x plus 2 which is the numerator now, multiplied by x plus 6. Okay. And now we want to write it as a singular fraction. And that is when, because we have multiplication of two fractions, we can take the numerator and then multiply it by the numerator, or I guess I can do it in this way. Take the numerator and multiply them together. Take the denominators and multiply them together. And what are we left with? We are then left with x minus 1 multiplied by x plus 5. And then we multiply it by the other numerator, which is x plus 2 multiplied by x plus 5. And then we just divide this over here. My laptop is overheating, kinda. And then we have x minus 3 multiplied by x plus 5. Multiplied by this numerator over here, denominator over here, x plus 2 multiplied by x plus 6. Alright. Guys, these RAM prices are too expensive, man. This is getting ridiculous. Now we can see if we can cancel anything out. Can we cancel anything out? So x minus 1. Is there an x minus 1 somewhere here? Absolutely not. X plus 5. Is there another x plus 5? Yes. So we can cancel these out. Because remember, they're all multiplying each other. Is there another x plus 2 in the denominator? Yes, there is. It's over here. So we can cancel those out. And there's an x plus 5 over here as well. But clearly, we've already cancelled it out with something else. We already had x plus 5's cancel. So we can't do it again. Okay. So therefore, we're going to have x minus 1 multiplied by x plus 5, which we are remaining with. And therefore, it is over x minus 3 multiplied by x plus 6. Okay. Right. So apparently there was a mistake that was made. I just realized it, by the way, because I was like, whoa, this looks a bit weird. So first of all, if you didn't notice it, x plus 6, x plus 5, that was a mistake. So therefore, let's fix on our mistakes, okay? So this over here is supposed to be x plus 6, okay? This one is supposed to be x plus 6, and clearly that was not supposed to cancel with the x plus 5 that we had over here, okay? So clearly we need to have that like that. But these x plus 5s can now cancel, and these x plus 6s can also cancel. So that's the only mistake that I actually noticed from this over here. So therefore, our answer will look like the follows, okay? Look as follows. We are left with x minus 1 over x minus 3. Because something didn't look right. And obviously, like I said, right, we all make mistakes, but then at the end of the day, we'll learn from them. And unfortunately, in my case, since I'm the tutor, I kind of need to be robotic. But I hope you can see that the most important thing is to double check your work in this case over here. But otherwise, that is all for the revision. We will go on to quadratic equations in the next session.